Okay, so a plane flies directly over my house at a constant altitude of 4 miles. If it flies at a speed of 400 miles per hour, at what rate is the angle of elevation of the top of my house changing when the horizontal distance from the top of the house to the plane is 3 miles? Answer in degrees per second. Okay, so let's go try to set this up. I guess a plane flies directly over my house. Let's say this is the house at a constant altitude of 4 miles. So we got the plane, which almost looks like a mouse, but in any case, we've got the plane be above the house a constant 4 miles. We know that's not changing. And it's flying at a speed of 400 miles per hour, so that's important. At what rate is the angle of elevation of the top of my house changing with the horizontal? So here's my house, here's the horizontal, and this plane keeps going this way. So at some point, maybe it'll be over here. And the angle of elevation with the horizontal, so it's basically the angle from where you're at looking somewhere. So that angle with the horizontal, let's say if I call it theta, it's asking for the rate of that angle of elevation. So it seems like in this problem, if I label that theta, I'm looking for d theta dt. That's my unknown. So it's going at 400 miles per hour. And if you're looking at the plane with the horizontal, it's making some angle theta. The top of my house, when the horizontal distance from the top of the house is 3 miles. So we need to label some things. We know this is fixed. 4 miles is fixed, it doesn't change. And this horizontal distance does change, so maybe we'll call it like x. This doesn't change, we know that's always 4 miles. And we're looking for d theta dt when that horizontal distance is 3 miles. So when x is 3 miles, we want to know what d theta dt is. So we need to come up with an equation that relates the picture I have, that's a right triangle, and the 4 miles, the x, and the theta. So in order to use theta, we think trig functions. So what trig function looks like will give me a good use of this side and this side. I guess it looks like it'll be tangent theta. So tangent theta is opposite over adjacent. Tangent theta is 4 over x. That equation relates all the information I have. It uses the constant 4 miles, the x that keeps changing, and the theta that keeps changing. And I'm not going to plug anything yet. I do that after I differentiate both sides with respect to t. So basically we have, I guess, tan theta equals, let's write that as a power function, 4x to the -1. Now we'll d dt both sides. Remember, theta is changing as time is changing, so it's a function of t. Same thing for this x guy. As time is changing, x is increasing, it looks like. So when I differentiate, tangent goes to secant squared. And then I have to pop out the derivative of the inside, so d theta dt, chain rule. Then I got 4 times -1 x to the -2 times dx dt. So we set up our picture, we came up with an equation that relates all the information, and now we differentiated both sides with respect to t. Now we're ready to plug in the knowns and find the unknown that I'm looking for. So let's see what we have so far. We've got secant squared theta d theta dt equals, I guess, -4 over x squared, and we got dx dt. And so let's go see which pieces of the info we have. We definitely have x to be 3, so that's taken care of. D theta dt is what I'm looking for. Dx dt, we have that also. So remember, the plane is moving horizontally at 400 miles per hour. So this is really our dx dt. It's the rate of the plane as it's going horizontally, the speed, 400 miles per hour. So we got that also. So this guy is going to be 400. Negative 4 over x is 3. 3 squared equals d theta dt. We're looking for that guy. And this, remember, is secant theta, all of it squared. And that's what I need to go find at this point. So remember, we're looking at a moment in time. This is theta, this is 4, this is 3. That means I should be able to find secant of theta. It's just the reciprocal of cosine of theta. In order for me to find cosine of theta, I need to know the hypotenuse, which is just going to be square root of 25, it looks like, which pops out a 5. So it's really the 3, 4, 5 right triangle. And with that, I can find out that cosine of theta is adjacent over hypotenuse, so 3 over 5, which means secant of theta will be its reciprocal, 5 over 3. So we have that information also. That's going to be a 5/3 squared d theta dt, the guy I was looking for, negative 4 over 3 squared times 400. And let's go do the algebra. So I'm going to move the 5 squared over 3 squared to the right, I guess. There's going to be some cancellation. So d theta over dt, reciprocal both sides. So we're going to end up with 3 squared over 5 squared here. We still have these guys. These are gone. And d theta over dt is going to be, once you punch that in, negative 64. And the units would have to be radians per hours, I guess, because it's an angle. And since I didn't use any other units of degrees, it seems like it's got to be the unitless measure, radians per hour, since our speed was in miles per hour. And the directions, though, I think said give answer in degrees per second to get a sense of how the angle is changing. It makes sense that it's negative, by the way, because as the plane moves further, notice what's happening. The angle keeps getting smaller and smaller as the plane is going further and further and your eye is moving with the plane. So it makes sense that it's a negative 64 radians per hour. Now let's go change it to degrees. So negative 64 radians per hour. Radians, let's put degrees up here. Pi radians are the same as 180 degrees. And let's get rid of the 1 hour having, I guess, 3,600 seconds. So we'll end up canceling the hours and the radians, and we'll end up with degrees per second once we punch that in. And if you punch that in, that's going to be approximately negative 1.02 degrees per second. So as time is passing by and the plane goes further and further away from you, the angle of elevation of your eye to the plane is decreasing by about 1 degree per second. And that's number 6 from your notes.